this video, we are going to explain about the project title Evidence Protection System using Blockchain Technology. Introduction. The project's primary objective is to establish a robust system for protecting evidence by incorporating blockchain technology. This integration aims to enhance the security and reliability of managing sensitive information. Conventional methods relied on centralized databases or physical documentation, which posed vulnerabilities like data tampering and unauthorized alterations due to lack of robust verification mechanism. These weaknesses underline the need for a more secure and tamper-proof solution. The project proposes a system that leverages blockchain's decentralized structure. It employs cryptographic methods, timestamps, and smart contracts to create a platform that ensures evidence remains tamper-proof, transparent, and authentic throughout its life cycle. This ensures the integrity and reliability of stored evidence. Ethereum, a prominent blockchain platform, is chosen for its robust features. The project taps into Ethereum support for smart contracts, its capability for creating decentralized applications (dApps), its active developer community, security enhancements, and compatibility with various blockchain projects. This choice underscores the project's reliance on Ethereum's capabilities to build and enhance the proposed evidence protection system. Objective. The primary aim is to improve the security, integrity, and traceability of various types of evidence across legal, financial, and sensitive data management domains. By employing blockchain technology, the project seeks to elevate the standards of safeguarding evidence. Traditional systems for managing evidence lack robust security measures, making them susceptible to tampering. Additionally, centralized setups raise trust concerns due to potential for alterations or manipulations. Maintaining transparent and traceable chains of custody also presents significant challenges. The project suggests implementing a system for managing evidence that leverages blockchain technology. This system intends to create tamper-proof records by utilizing a decentralized ledger. It relies on cryptographic security measures to ensure the authenticity and integrity of evidence. Moreover, it provides transparency for authorized access while offering resilience against vulnerabilities typically associated with centralized setups. Requirements. Software requirements of the project are Python IDLE 3.7.0 version, Node.js, Visual Studio Community version, Ganache, MetaMask Chrome extension. Hardware requirements of the project are processor of Wi-Fi and above, RAM of 8 GB and above, ROM of 20 GB and above. Framework is Flask. Backend languages used in the project are Python, JavaScript, and Solidity. Front-end languages used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Methodology. To implement this project, we have designed the following modules. The first module is user sign-up. This module allows individuals to create accounts within the system. Users provide necessary details, including personal information, credentials, username, password, and any additional required data. Upon successful registration, their information is stored securely within the system, leveraging blockchain for data integrity. User sign-in. Once registered, users can sign in using their credentials. This module verifies the provided information against stored records to authenticate users. Upon successful authentication, users gain access to the system's functionalities based on their assigned permissions and roles. Add information. This module enables users to input or upload evidence-related information into the system. It involves uploading documents, entering data, or attaching files relevant to the evidence being managed. The information added goes through processes ensuring its authenticity, immutability, and secure storage, often leveraging blockchain's capabilities. Check information. Users utilize this module to access and verify information stored within the system. It provides them with the ability to search, retrieve, and view specific evidence or related data. The module ensures transparent access to authorized users while maintaining the security and integrity of the stored information. The integration of these modules within the system ensures a comprehensive and secure approach to managing evidence while leveraging blockchain technology to maintain the integrity and security of the stored information. Blockchain integration. Blockchain's decentralized ledger involves storing evidence records across numerous nodes. This distribution ensures that there's no single central point of control, significantly enhancing security. Each node contains a copy of the ledger, preventing data manipulation or tampering without consensus across the network. Within the blockchain, cryptographic hashing and timestamps are applied to evidence. This process creates a unique, irreversible digital fingerprint for each piece of evidence. Once stored, any alteration or deletion becomes computationally invisible, establishing tamper proof records. Smart contracts automate predefined rules and actions related to evidence management. By encoding these rules into smart contracts, the system ensures consistent execution, transparency, and reliability in managing evidence throughout its life cycle. Blockchain's transparent nature allows authorized users to access evidence records. This access enables verification of the evidence authenticity and integrity. The transparent and auditable nature of blockchain fosters trust among stakeholders and ensures transparency in evidence handling. Leveraging cryptographic techniques inherent in blockchain technology, the overall security of evidence is enhanced. These techniques ensure that unauthorized access or modifications to evidence are prevented, maintaining the integrity and confidentiality of stored information. In this project, we have utilized Ganache. Ganache serves as an intuitive interface for Ethereum blockchain activities. It offers a graphical display of crucial details such as accounts, transactions, and smart contracts. This user-friendly interface simplifies the exploration and management of Ethereum blockchain functionalities for developers and users. Ganache provides insights into individual blocks within the Ethereum blockchain. It shares essential information like block numbers, timestamps, transactions contained within each block, and gas usage. This comprehensive data assists in performing in-depth blockchain analysis, understanding the sequence of events, and assessing network performance. Furthermore, Ganache functionality extends to facilitating data retrieval from stored blocks. Developers can access specific block information, enabling them to extract and analyze detailed data relevant to their applications or smart contracts. MetaMask MetaMask functions has both an Ethereum wallet and a browser extension. It allows users to manage their cryptocurrencies, primarily Ether, ETH, and interact with decentralized applications, dApps, seamlessly. Users can store, send, and receive Ether while also accessing various Ethereum based applications directly through their web browser. In the project context, MetaMask serves as a secure means for Ethereum transactions. It enables users to conduct transparent transactions involving ETH within the evidence protection system. For instance, it facilitates the reduction of ETH for various actions or payments within the system, ensuring transparent and secure financial operations. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the contracts folder, which consists of Solidity code. It handles data structures, functions, and events with modifiers for validation. This is the static folder, which contains files related to CSS, JavaScript, and Bootstrap. These files contribute to the visual and interactive aspect of the application. This is the templates folder. Within this folder, we will find all the HTML pages used throughout the project. It includes pages like index.html, home.html, and more representing various sections of the website. This folder also contains Python code files that will be executed during the runtime of the application, supporting its functionality. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. To execute this project, we need to host the server. To host the server, open Ganache. So here we can see that server is hosted. Now minimize this. Go to the code folder. This is run.bat file. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. Double click on it to start the application. The Flask framework will host the application locally at the default address localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. So here we can see we are having user sign up link and user sign in link. First click on user sign up link to add a user. So here we need to enter all these details to add a user. Department username, which is Uma, password, number, email ID, address. After entering all these details, click on add user button to add the user. So here we can see sign up completed and details are saved to blockchain. Now click on new user sign up link to add a new user. So here we need to enter all these details. Department username, which is Murli, password, number, email ID, address. After entering all these details, click on add user button to add the user. So here we can see sign up completed and details are saved to blockchain. Now again click on new user sign up link to add one more user. So here we need to enter all these details. Department username, that is Krishnamurthy, password, phone number, email ID, address. After entering all these details, click on add user button to add a user. So here we can see sign up completed and details are saved to blockchain. We have registered 3 different users with 3 different username and password. Now click on user login link to log in as the first user. So here we need to enter the username and password of the first user. So username is Uma. We need to enter the password and then click on login button. We have logged in successfully as the first user, which is Uma. Now here we are having add information link and check information link. First click on add information link to add the information. So here we need to select the user to whom we want to send the evidence to. So here I'm selecting the user as Krishnamurthy and here we need to upload the evidence. So click on choose file. So here I'm selecting the evidence and click on open button. Now click on add evidence button to add the evidence. So here we can see evidence added successfully to blockchain and this evidence is sent to the user Krishnamurthy. Now click on logout link. Now again click on user sign in link to log in as Krishnamurthy. So here we need to enter the username and the password and then click on login button. We have logged in successfully as Krishnamurthy. Now click on check information link to check the information which is sent by the first user Uma. So here we can see sent by Uma, file name, that is report 1, and here we have the option to download the file. So click here on download link. So here we can see that the evidence is being downloaded. Now click on logout link. Now again click on user sign in link to sign in as the second user. So here we need to enter the username, which is Murli, and the password, and then click on login button. We have logged in successfully as Murli. Now here, again click on add information link to add the information. So here we need to select a user whom we want to send the evidence to. So here I'm selecting the user as Uma. Now click on choose file to upload the evidence. So here I'm uploading the evidence. Now click on open button. Now click on add evidence button to add the evidence. So here we can see evidence added successfully to blockchain, and this evidence is sent to user Uma. Now click on logout. Click on user sign in link to log in as the register Uma. So here we need to enter the username and the password, and then click on login button. We have logged in successfully as Uma. Now click on check information link to check the information. So here we can see sent by Murli. Here we have the file name, and here we are having the option to download the evidence. So click on download link to download the evidence. So here we can see that the evidence is being downloaded. Now click on logout link. Now click on user sign in link to register as the first user. Enter the username, which is Uma, and the password, and then click on login. Now click on add information link to add one more evidence. So here we need to select a user to whom we want to send the evidence. So I'm selecting the user as Murli. Now click on choose file to upload the evidence. Select the evidence, click on open. Now click on add evidence button to send the evidence to the user Murli. So here we can see evidence added successfully to blockchain. Now click on logout link. Now again click on user sign in link. So here we need to enter the username and the password, and then click on login. We have logged in successfully as Murli. Now click on check information link to check the information. So here we can see sent by Uma, and here we are having the file name, and here we are having the option to download the evidence. So click on download link to download the evidence. So here we can see that the evidence has been downloaded. Now click on logout link. In this way, we can add multiple users, and the users can send evidence to each other, and we can check the evidence in the users whom we have sent the evidence to. So here in the Ganache, we can see that the data is stored in these blocks permanently. We can retrieve the data whenever we want. Click on block number 29. Here we can see the block hash and the transaction hash. Click on transaction hash. Here we can see the transaction data, the sender address, as well as the to contract address. And here we have the gas consumed, gas price, gas limit. Minimize this. For checking the fluctuations of the ETH price with each transaction, we need to open MetaMask. Here we have the Chrome extension for MetaMask. Click on it. In the MetaMask, we can see I have a balance of 100 ETH in my MetaMask wallet, which represents the deducted amount after each transaction. In the context of blockchain, transactions refers to the action or operations that are recorded on the blockchain ledger. We can see ETH balance remains unchanged after each block creation because the project's actions don't involve significant ETH transfers. This is normal as not all operations lead to substantial balance changes. Conclusion of the project. The conclusion outlines the successful implementation and testing phases of the evidence protection system based on blockchain technology. It signifies that the system has been developed, deployed, and subjected to rigorous testing to validate its functionality and performance. The project emphasizes how blockchain technology effectively ensures the creation of tamper-proof evidence records. It highlights the system's ability to enhance security by utilizing blockchain's inherent features such as immutability, cryptographic security, transparency, and reliability in securing evidence. The conclusion provides a summary of the project's achievements and positive outcomes. It includes milestones reached during the development phase, showcasing the successful creation of a decentralized and transparent system for managing evidence, indicating a step forward from traditional methods. It highlights the improvements brought about by utilizing blockchain technology in evidence management. These improvements encompass enhanced integrity, unaltered records, heightened security through cryptographic measures, and improved accessibility, transparent access for authorized users.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.